Hey everybody, it's Mr. Roy. Let's do a lesson on the standard form of a quadratic. So the stuff we've been working with recently is our factored form, right? You're familiar with something that looks like this, say y equals -2, and then we've got x minus 4, and we've got x plus 8. That's an example of something in our factored form. And a factored form is really useful because we can really easily see where the zeros, which also called the x-intercept, are, right? In this case, they would be 4 and -8. You can tell that just by looking at the brackets. But there is another form of a quadratic that is a really common one, and that's called our standard form. And that's the one we're going to look at today. So the first thing we need to think about is the type of algebra that's going to be involved in doing standard form stuff. Okay, so this is kind of what we looked at yesterday and noted that that's something we needed a little extra practice on. So uh, when you got a quadratic, if it's in factored form and we expand it by removing all the brackets, we're going to end up with this new form called standard form. And it's in the form, you've got our y equals, same as normal, and then we've got our x squared term, our x term, and then just a regular number. And in place of putting coefficients in front of that when we don't know what the particular ones would be, we just use letters to represent them. A, B, and C are just numbers, right? They could be 1, they could be 15, they could be 1.5, they could even be 0, but those are just going to be numbers. Okay, so when something is written in that form, we say that the quadratic is written in standard form. It's just another way of writing the same sort of quadratics that we've seen. So we could have quadratics that are in equivalent forms, basically they're the same quadratic, but they're just written a little bit differently. Okay, so how are we actually going to put things in standard form? So we're going to have to expand those binomials, right? So a binomial is just an expression of two terms. And in factored form, we've got a binomial multiplied by another binomial. And so what we're going to do is we're going to multiply all the terms in the first bracket by all the terms in the second bracket. And of course, you remember that we have this handy thing to remember called FOIL, which is first, outside, inside, last. So we're multiplying the first terms in each bracket, the outside terms in each bracket, the inside terms in each bracket, and the last terms in each bracket. Now, you'll remember that when I like to do this, I like to think about this, we want to think about this in a slightly more sophisticated way, that really we just have to multiply each thing in the first bracket by each thing in the second bracket. So we can go through the first bracket one term at a time, take each of them and multiply it by everything that's in that second bracket, because you will soon get things that are beyond binomials. We'll get into trinomials that have 3 terms, and we need to be able to work with those as well. And FOIL will only work for binomials. Okay, so let's get into a little bit of practice. Let's try some of these out. Okay, so here we've got our first one, and it says expand. We've got 2x plus 1 and x minus 4. So we're going to draw those little arrows. Those are really helpful in making sure that we're getting all the things multiplied properly. So that's first, outside, inside terms being multiplied, and last terms being multiplied. Let's do our multiplication now. We've got 2x times x. That's our first one. 2x times x. That's going to be 2x squared. And then we've got 2x times -4. So a positive times a negative, that's going to give us a negative answer. 2 times 4 is 8, so that'll be 8x. Now we've got 1 times x. 1 times x is just x, and it's positive. And now we've got 1 times -4. That's going to give us a negative answer. 1 times -4 is -4 minus 4. Okay, so here we go. We've got 2x squared minus 8x plus x minus 4. A good start. Now what we need to do is collect our like terms. Of course, like terms are anything that has the same variable to the same exponent. And that would include grouping all of our regular numbers together. So our x squared, we've only got one x squared term. That's 2x squared. So nothing to combine that with. We've only got one regular number, -4, so nothing to combine that with. We've got 2 terms that are written as x's. So we can combine those like terms. So let's do that. I'm going to rewrite the 2x squared. I'm going to rewrite the -4. And in the middle we've got minus 8x plus x. Basically, we've got negative 8x's, and we're going to add 1. That's going to put us at minus 7x. Okay, so this is our quadratic. If we graphed what we originally started with, y equals 2x plus 1 times x minus 4, and if we graphed y equals 2x squared minus 7x minus 4, those are going to look the same. They are equivalent expressions. Okay, so that's our first one. Let's go to our second one here. This one maybe looks a little more straightforward. So we'll go first terms, x times x, outside terms, x times negative 2, inside terms, 5 times x, and last terms, 5 times negative 2. Let's do that multiplying. X times x is x squared. X times negative 2 is minus 2x. 5 times x is plus 5x. And 5 times negative 2. Positive times a negative gives us a negative answer, minus 10. Let's collect our like terms. Our x squared and our minus 10 don't change because they have no other like terms to group them with. We've got minus 2x plus 5x. So we're going to go down 2 and then up 5. That's going to leave us with positive 3x. So that's our final expression. Now you'll notice that each time we're doing this, we're ending up with 2 x terms. That's going to be really common. In fact, that's usually the situation we're going to be in whenever we're multiplying 2 binomials together like we are in this situation, okay? When we're trying to put something in standard form. Usually your x squared term will be the same. We won't have to do anything with that. Our regular number, same thing, but our x terms will need to combine 2 x terms. And that's because we have 1 x in one bracket, 1 x in the other bracket, and they're going to be multiplying the regular numbers. Okay, let's go to a green pen here. Here we are. Let's do 3x minus 5 and 4x plus 1. By the way, it's a really good idea while we're going through this video. I would recommend that each time we get to a question, now that we've done a couple of them together, that for C, D, E, and F, I'm going to suggest that you pause the video, you try it yourself on paper, and then you watch me do it. And if you were comfortable with it, you can kind of fast forward through me doing it because you've already tried it. Okay, so try that now so you can try these beforehand yourself, and you can watch me do each one in order to try and pick up any support that you need. Okay, so I'm going to move a little bit quicker now. Got 3x times 4x, 3x times 1, minus 5 times 4x, minus 5 times 1. So 3x times 4x, well 3 times 4 is 12, and x times x is x squared. 3x times 1 is just 3x. Negative 5 times 4x will give us minus 5 times 4 is 20x. And negative 5 times 1 is negative 5. Let's combine our like terms. Our 12x squared stays the same, so is our minus 5. We're combining the x terms because they are like terms. So we're going to end up with minus 17x. Okay, let's head over to D. Now, D is a little funny because we have this 3 out front. I'm actually just going to ignore that for now. I'm going to multiply everything in the brackets, but I'm going to keep that 3 where it is. Let's go to a new color. Let's go to back to purple. I'm going to leave that 3 out front where it is. And I'm going to put some big brackets, I'm going to use square brackets just to differentiate it, make it nice and easy to see. And now what I'm going to do is I'm going to multiply through there. So I'm going to go x times 2x, x times negative 3, negative 1 times 2x, negative 1 times negative 3. So I'm going to do my regular FOIL, and then once that's all done, I'm going to have to multiply each of those things I get by 3. Okay, so just do the multiplying one piece at a time. We'll leave the 3 over there for now. X times 2x is 2x squared. X times negative 3 is negative 3x. Negative 1 times 2x is negative 2x, or minus 2x rather, and negative 1 times negative 3. Negative times a negative gives us a positive, that's going to be positive 3. Okay, before we multiply this 3 through, let's just collect our like terms to simplify things. So we've still got our 2x squared, we've still got our plus 3, Our like terms are the x's, minus 3x minus 2x. That's going to give us minus 5x when we add those like terms together. Okay, now we can actually multiply this 3 through the brackets. So here we go. We're going to multiply it like that, and like that, and like that. That 3 is going to have to multiply everything in the brackets. So 3 times 2x squared. Well, 3 times 2 is 6. So we end up with 6x squared. 3 times negative 5x. 3 times 5 is 15. So we end up with 15x. And 3 times 3 is 9. So there we have it. That is our standard form from our factored form. Okay, I'm going to organize my other two here, and then we'll jump in on our last ones. Nope, looks like I've been recording the whole time. I thought I'd paused it there. Never mind, folks. I guess we're just gonna keep rolling along. So sorry for the long wait there. I thought I had paused our video. All right, here we are rolling along. Okay, E is really similar to the one we just did. So we're going to multiply through the brackets. We'll do our foiling, and then we will, afterwards, multiply everything by negative 2. So let's put that negative 2 up front. Let's use some nice big square brackets. It's fine to use square brackets. It doesn't really change the meaning. And then we're going to go x times negative 7, 4 times x, 4 times negative 7. Okay, here we go. So x times x, that's going to be x squared. X times negative 7, negative 7x. 4 times x is plus 4x. And 4 times negative 7, that will be negative 28. Let's collect our like terms. We got our x squared. Negative 7x plus 4x, that's going to be minus 3x, minus 28. Okay, so now we can multiply everything through by that negative 2. And so that should work pretty easily. I'm not going to draw the arrows on this one because we've kind of done it before. I'm just going to multiply that negative 2 by everything. So we've got negative 2x squared. We've got positive, because negative times a negative is a positive, 6x, and plus 56. So this is our quadratic expanded all the way out. One thing to notice here is that this value and this value both tell us, because they're negative, that our quadratic opens down. So that's a nice easy way to look at it. Even in standard form, you can still look at it and tell whether it opens up or down just by looking at that value out front. Okay, for this F1, it's x plus 2 squared. So the trick to this one is the x plus 2 squared just means x plus 2 times itself. So we're going to write it twice just to make it easy to see. So really what this is x plus 2 times x plus 2. That's what x plus 2 squared means. It just means times itself. Now let's multiply through the brackets. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Let's collect our like terms. And now we've got it in standard form. Okay, let's keep making this a little more difficult for ourselves. Let's go to this one here. And let's try something that's got both x's and y's in the math, which can happen when we're dealing with like more complex expressions. So what we're going to need to do for this one is very similar, but we're tracking two unknowns, so that can get a little tricky. First thing we're going to do, same as we did before, we're going to write it twice. Good, we wrote it twice. Okay, let's multiply through the brackets. We're going to have 2x times 2x, 2x times negative 3y, negative 3y times 2x, negative 3y times negative 3y. 2x times 2x, 2 times 2 is 4, x times x is x squared. 2x times negative 3y, ooh, that's a little tricky here. 2 times 3 is 6, but it's a positive times a negative, so it's going to be negative 6. And you say, what do I do with those variables, the x and the y? Well, we just write them together, x times y. By writing them together like that, that just means all those parts are multiplied. Now we got the same thing, negative 3y times 2x, that's going to give us the exact same thing. You'd think now maybe I should put the y first and the x second, and actually the order doesn't matter. With multiplication you could switch the order. 4 times 5 is the same as 5 times 4. So you can switch the order and it doesn't matter. So let's just write it to be the same. And now we've got negative 3y times negative 3y. Negative times a negative gives us a positive, positive 9y squared. Let's collect our like terms. We do have like terms. We have an x to the 1 and a y to the 1, and an x to the 1 and a y to the 1. So those ones are like terms, so we can still collect those together. When you add them together, that's going to be negative 12xy plus 9y squared. Okay, now we're on to h over here. This one, again, gets a little trickier because we've got a squared thing and then we've got a value out front. So we're going to deal with the brackets first and then we'll multiply through by 4. So let's rewrite this. Okay, now we're ready to multiply through the brackets. So let's put our 4 out in front. I'm going to use square brackets to make it nice and easy to see. X times x is x squared, 2 times x is 2x, x times 2 is 2x, 2 times 2 is 4. Let's collect our like terms. 2x plus 2x, that makes 4x. Now we're going to multiply that 4 through the brackets. Four times x squared is 4x squared. 4 times 4x is 16x, and 4 times 4 is 16. Okay, now we got it in standard form. Now, it gets even tougher here. Here we've got 3 different things. Don't try to deal with all of these at once. We're going to do these kind of one section at a time. So to start off, we're going to kind of ignore this one here, and we'll just deal with the other 2. Now, you could do this in any order. You could multiply the first binomial by the second one, and ignore the third one to start, or you could multiply the first one and the last one and ignore the middle one to start. I think it's just easier if we just deal with the latter 2 first. So here's what I'm going to do. I'm going to rewrite this, but I'm going to keep the x plus 2 by itself right here. And then I'm going to multiply the 3x minus 1 and the x minus 4. So let's do that. By not trying to do this all at once, we make our lives a lot easier. So 3x times x is 3x squared. 3x times 4 is 3 times 4 is 12, so 12x. Negative 1 times x is minus 1x. I'll just write that as minus x. And minus 1 times 4, negative 4. Okay, let's simplify before we try and do anything else. Let's collect our like terms inside the bracket. So we got 3x squared, negative 12x minus 1x gives us 11x. Okay, so the one on the right here is called a trinomial because it's got 3 terms. So this is where FOIL doesn't really work anymore. But what we're going to do is we're going to multiply everything in the first bracket by everything in the second bracket. So that means we're going to multiply this x times that, and times that. It's going to multiply everything. And then this 2 is going to multiply that, and multiply that, and multiply that, So let's do the math. X times 3x squared. Okay, that's still going to have a 3. But x times x squared, well, you actually ended up with x times x times x. That's going to be written as x cubed. That's what cubed means, times itself 3 times. Now I've got x times 11x, so that's going to be 11x squared. And x times minus 4, so minus 4x. Now we've got this 2 over here. It's going to multiply everything as well. 2 times 3x squared is going to be 6x squared. 2 times 11x will be 22x. And 2 times negative 4 will give us minus 8. Okay, whew, look at this mess. Let's try and find some like terms. There's going to be a few, so I'm going to use my highlighter. First, I'm going to try and find squared terms. There's an x squared and there's an x squared. So those I can group up together. And here I've got a regular x, and here I've got a regular x, and those are the only ones that have matches, or I have like terms that I can deal with. The single minus 8 here at the end doesn't have a like term, and the 3x cubed doesn't have a like term. So we'll write the 3x cubed. We usually write them in order of the highest exponent first. Now, I could rewrite this so that the like terms were together. I could move the things around, but I think I can just do it by looking at it. So I've got 11x squared plus 6x squared. Let's add those two together. 11x squareds and 6 more x squared, so that's going to be 17x squared. And then we've got minus 4x, and we've got plus 22x. So that's going to be plus 18x when I add those two together. And then minus 8. Okay, this is not a quadratic, right? This is a third degree polynomial. So this is something that's going to look quite different from a quadratic. But we do want to be able to handle this this math. It's a little bit tricky. Okay, now that we've got a good handle on this math, on this algebra, let's go to a little bit of problem solving. All right, here's our first question. A parabola has zeros of 2 and 4. It passes through the points 6, minus 16. Determine the equation in standard form, the direction of opening, the axis of symmetry, the vertex, and the y-intercept. Now you might have some idea about how to do a lot of these once we have an equation in factored form. Currently we don't have that. So let's try and see if we can come up with an equation in factored form, and then we know we can turn that into an equation in standard form. Okay, so let's start off with A. We're going to try and get the equation in standard form. So we'll say, to start, we're going to find equation in factored form. Because we know that's one way we can do it. So here's our equation. Our equation in factored form is going to be y equals some number a. We don't know what that is. But then we've got our zeros here, right? So we have zeros of 2 and 4. So that means I got to use the opposite sign when I put it in my equation. So I'm going to have minus 2 and minus 4 in here. Okay, so far so good. That's basically what our equation is going to look like when it's in factored form. But I'm not really sure what my a value is, so that's a problem. So I can find that a value by substituting in my point, okay? So I can take this point right up here, 6 and minus 16, and I can enter that. So my y-coordinate is minus 16. That's going to be one of the points on this graph. And my x value at that same point is 6. So by substituting this value in, it's going to allow me to find what my a value is, because this one point gives me some information. Okay, so I've got 6 minus 2, so that's going to be 4. And then I've got 6 minus 4, so that's going to be 2. A times 4 times 2. Okay, so 4 times 2 is 8, so this is going to be 8a. So minus 16 equals 8a. How do I get rid of that 8 and get a by itself? I'm going to divide both sides by 8. So we say, okay, we're left with a equals negative 16 over 8. That's negative 2. So that's a pretty important thing to figure out. I'm going to put a little box around that. And now we know we've got an equation. It's going to be y equals negative 2 times x minus 2 times x minus 4. So let's write that full equation in its factor form. So we're going to say y equals negative 2 times x minus 2 times x minus 4. Okay, now I can actually do this some algebra here to turn all of this into a standard form equation. So we're going to multiply through the brackets, just like we did before. So we'll go x times x is x squared, x times negative 4 is minus 4x, negative 2 times x minus 2x, and negative 2 times negative 4 is plus 8. Let's collect our like terms. Minus 4x minus 2x, that's going to be minus 6x when we add those together. Now let's multiply the negative 2 through. Negative 2 times x squared, negative 2x squared. Negative 2 times 6x, that's going to be positive 12x. Negative 2 times positive 8, that's going to be negative 16. Okay, so this is our equation in standard form. So what did we do? Let's do a quick recap. We wrote as much as we could knowing the zeros of our equation in factored form. So we substituted in our zeros. Then we substituted in a point. Any point would have worked. Any point at all would have worked. We happen to know a particular point, 6, negative 16. So we put in our y and our x values for that. We used that to do a little bit of algebra to figure out our a value. And then we just multiply through the brackets to turn our equation into standard form. So far, so good. That's our biggest one though. Okay, let's move on to some quicker and easier ones. What's our direction of opening? Well, we can actually just look at our a value. So let me get out my highlighter here. We can look at either equation. We can look at it when it's in factored form, or we can look at it when it's in standard form. Both of them are negative values. So since our a value is negative, that tells us that it's going to open down like a frowny face. So let's write that out. We'll say, since a equals negative 2, opens down. And then we'll draw a little frowny face quadratic like that. Okay, C is our axis of symmetry. Our axis of symmetry is one that's pretty easy to find if we know our zeros. And we do know our zeros. They're 2 and 4. So axis of symmetry, knowing that our zeros are at 2 and 4, I take 2 and 4 and I add them together and I divide by 2. It's kind of like getting the average, right? So 2 plus 4 is 6, divided by 2 is 3. So my axis of symmetry is at x equals 3. That's also the x-coordinate of my vertex, right? So finding my vertex next will actually be much easier because I've already got the x-coordinate of it. It's 3. So here's what we're going to do to find our vertex. We can take our equation and just put a 3 in wherever we had next. Now you might say, which equation? Because we actually have 2 of them. They'll give us the same answer. And let's actually show that that's true. Let's start by doing it with the equation in factored form. Okay, there's our equation in factored form. Let's sub in when x equals 3, see what our equation gives us. So anywhere I see an x, I'm going to replace it with a 3. Okay, so we got negative 2 times 3 minus 2 is 1, and 3 minus 4 is negative 1. So it looks like our y-coordinate is going to be 2. Because negative 2 times 1 times negative 1 is just going to give us 2. Okay, so that looks like our vertex. say vertex is at x coordinate of 3, y coordinate of 2. Now you might say, okay, hold on, Mr. I'm not so sure. What about the other equation? Well, let's actually try it. We should get the same answer, but let's check it just to be sure. Okay, so we've got negative 2x squared plus 12x minus 16. I'm going to try and squeeze this in as best I can. Here we go. All right, well, I'm going to do my exponents first. So 3 squared is 9. So 2 times 9 is minus 18. 12 times 3 is 36. Minus 16. Oh, that works out to 2. So look, we got the same answer, no matter which equation we used, and we should, because those are equivalent equations. We should get the same answer no matter which version of the equation we use. Okay, so that gave us our vertex. Now we need to find our y-intercept. Now again, we can use either equation. It doesn't matter. We should get the same answer. We should ask ourselves, though, which equation would be easier to use? To get the y-intercept, we need to sub in x equals 0. So actually, either of these would be pretty easy, but for me, the standard form is a bit easier because subbing in for x equals 0 is going to make those first two terms just disappear. So let's do that. Here's our equation. Okay, to find the y-intercept, we're going to let x equal to 0. Okay, so anywhere we see an x, we're going to put in a 0. You're probably way ahead of me. You're probably saying, Mr. Roy, anything times 0 is just 0, so we can just get rid of those. Don't even bother writing them out. And you'd be right. I'm okay with that. But I did want to show you the whole thing. So we end up with y equals negative 16. Okay, so what is our y-intercept? Our y-intercept is going to be at the point x value of 0, because it's always an x value of 0 for our y-intercept, and negative 16 is our y value. Okay, so we found out everything we need to know about that quadratic. We probably could have just graphed it in Desmos once we got our equation and found those things, but to actually just get to that equation, given some limited information, we're not able to use Desmos to help us with that. So we do actually need to do a lot of this by hand always, and it is good to know how we're getting those other answers. So doing this by hand is an important flexing of those math skills and understanding of the basics. Okay, we got one more section I want to take care of. And so here we go. We're going to look at a little, I'm going to give you a little formula that makes finding the axis of symmetry a little bit easier. So here's our standard form, right? It looks like this. So A is going to tell us our direction of opening. If it's positive, it opens up like a smiley face. If it's negative, it opens down like a frowny face. Here's a little formula you'll want to write down on your learning goal sheet. So that's an important one to make sure you have handy. You're going to want to know this one for sure. If you take the negative of your B value and then you divide it by 2 times your A value, that's going to give you your axis of symmetry. So this is a little handy dandy formula that you're going to find helpful when you're working with these sorts of things. That's an easy way when you've got your standard form to get right to your axis of symmetry, rather than having to try and put it in factor form, because you don't know how to do that yet. You don't know how to work backwards. We are going to learn that, but we're not there yet. So this handy dandy formula is going to come in easy for axis of symmetry. Of course, we can find the vertex by using the axis of symmetry and then subbing that value for x into the equation to get our y value. And our y-intercept is always c, because when we put in 0 for the other terms, they disappear, and all we're left with is that number at the end. Okay, so this is going to help us solving a question. We're going to do this one pretty quick. So here we go. Here's our example. Here's an equation. Y equals negative 2x squared plus 6x minus 3. We're going to determine three things about it. First of all, the direction of opening. Well, I can tell since A is negative, that tells me it opens down. So it's a frowny face quadratic, like that. The axis of symmetry, let's use our equation to figure out the axis of symmetry, our newest equation. So we're going to say, okay, for our axis of symmetry, that's going to be x is equal to negative b. What's our b value? It's 6. So negative 6 over 2 times our a value. Our a value is negative 2. So what does that work out to? That's going to be negative 6 divided by negative 4. So we're going to end up with 6 over 4 because we've got a negative divided by a negative, so the negatives will cancel out. And so that's going to be 3/2. Oh, I'm jumping around. That's going to end up being 3/2, or you could write it as 1.5 if you want to make it a bit easier to work with. Okay, finally, we're going to find that vertex. So here we go. Let's change colors again. We'll go with purple this time. And let's find our vertex. I said purple. Curse you, system. Okay, here we go. Good. Okay, so we know what our equation is, right? And we also know our x value of our vertex is 1.5. So here we go. We're going to go y equals negative 2. And anywhere I see an x, I'm going to put in a 1.5. Now if we work all that out, 1.5 squared times negative 2, that gives us a negative number. 6 times 1.5, we get that number. And negative 3, we work all those out. We're actually going to end up with 1.5 as our answer, which is kind of funny because that's what we put in for x, but that just happens to be coincidentally what it works out to. So our vertex is going to be at 1.5 and 1.5. So nice and quick and easy. That was a quick way to find out a lot of information about this quadratic. Okay, so I hope that those examples have helped you understand this a little better. Now it's time to practice. We're going to get to work. So stuff that I'd like you to work on is listed on Edsby. It's also at the bottom of your skeleton note sheet that you were using for this. So let's haul open those textbooks and let's get to work and let's do some practice. Let's go for it.